Hi folks, Yvette here, bringing you another variation on the game of life that will teach you something you didn't know. On today's menu, we have approval testing. And the really exciting news is that I have the ultimate guru of approvals, Llewellyn Falco, with me via double screen share. Hi Llewellyn.
Good morning, Yvette.
Before we dive in, if this is your first time on this channel, you might first want to watch the short explainer video about Game of Life I linked in the description, so you know what is the problem we are trying to solve. In this series, I explore different implementations of this kata to teach various programming concepts. Unlike in previous episodes, this time we are pair coding with Llewellyn. We came up with the idea while preparing for a lean poker event he was organizing for his meetup group. Topple was nice enough to give us a free subscription to their amazing screen sharing tool designed with pair coding in mind. Thanks for that. Now with all of that out of our way, let's get started.
I'm Llewellyn Falco, and I'm a technical coach, which means I sit with the programmers and we program together. And I've gotten a whole bunch of value over practice, which is something I just feel people don't do nearly enough in our industry.
I would like you to first walk me through what approval testing is, and then we can get started.
There's many different types of programs that do what is called approval testing, or sometimes referred to as golden master testing, or sometimes referred to as snapshot testing. They're all sort of saying different words for the same thing. Okay, so at the very most basic level, approval tests is the same as an assert equals, right? So I can do something here where I can say like assert equals hello world equals my text. And then here I can say my text equals hello world. And everyone's sort of seen this. But when this text starts to get really complicated, it gets a lot harder. So the very easy idea here is well, let's just put it into some sort of file. Then we can sort of say let's load a file. But now we have the problem of well, what is this name going to be, right? And something that'd be easy is at least this name, if it related to this. So maybe it'd be straight test.expected.text, right? I mean, we just have to manage that. So what approval says is, well, let me manage that for you. But then the next thing is we have this long file, and if it doesn't match with what's expected, the way that normal unit tests does, they'll show you the difference really easy if it's a small amount of text, but they're not going to do something for a large amount of text. And of course, we have tools that will do that for us. All of our diff tools handle large amounts of text that are different. And so then what you're going to want to do is sort of save your thing into the expected and the actual. And then when it fails, you're going to want to open something that shows you, hey, how has this changed? An approval test just does all that for you. And so just to sort of see it in quick action, I'm going to change. I don't actually know what this does at the moment. So I'm just going to change it with the actual name of this function. And then I'm going to run it. Now I expect this to fail because it's not going to say the same thing it used to do. And it does. And like I said, when it fails, it pops open a diff tool. And again, you can see over here on the right, here's the expected. We don't say expected, we say approved. But you have this file name that's automatically there. You can actually see it has the name of the test with approvals in it, and the name of the class so that we don't have namespace conflicts. Dot approved, and we want hello world. And then over on the other side, we have the file name. And again, name of the file, name of the test, but dot received. And this is what we actually got. And so this helps us to see when things are different. But the other thing that's really nice is if for some reason this is what we wanted, you can very easily just take it and move it over and be like, yeah, no, that's what I want. I find with approval test, I notice two things occur on red. In test, it's usually on red. It just means that my production code is wrong. But with approval tests, when I get red, it could be, oh, I got what I actually wanted and I need to change my expectations. So I changed a feature or I built a new feature and it gave me new results, but those new results are what I want. Or it can say something changed that I didn't expect, and now I have to go to my code and say, why did something change? But that's it, right? It allows us to run code and take more complicated objects. And it sits underneath unit testing frameworks. So it's not instead of, it's in addition to.
That also means that some of your tests will use approvals and some of yours will not.
Yes, and it really depends on how small the thing I'm testing is. So if I want to know if an object came back, I'll usually use approval test. If I want to know that a number or a string or a Boolean came back, I'll usually use a traditional assert. So one other thing that is worth talking about is the testing circle, because I have found that this is really helpful in working. Very often when I'm writing a test, the first thing I need to do is come up with a test scenario. And the easiest place for me usually to do that is on a whiteboard. So I'll sketch something down to be like, hey, this is what I think is going on. And once I have that scenario, I need to turn it into English. And then I'm a big believer in consume first. So I take that English and I turn it into code. And usually it's very similar. Each line of English, I have one line of code. So if I have 4 lines of English in my scenario, I'm going to have 4 lines of code. And then that code usually produces something that can be represented fairly similar to the whiteboard, usually in a sort of ASCII art kind of way, but like it's very reminiscent of the whiteboard. And approval test really helps me just to do that. I don't have to constrain my scenarios to something that is artificially easy to test. How would you like to start?
We can start with you writing a test, and then I can take over and write the code, and then I will write the next test.
Okay, I'm going to do sort of what we did in the testing scenario. So let me pull up some sort of whiteboard. For Game of Life, we usually have some sort of board, and then we're going to put some stuff on that board. We'll just put one thing on the board, and then if we advance the turn, I expect that board to be empty. So that's going to be my test. So delete our sample test. We just are going from the sample test here, and I'm going to start by turning that into English. We're going to create an empty Game of Life. We're going to place a cell on it. I don't know if we really sort of specify. That's always an issue. How about we say that it was at 2-1, and then we're going to advance the turn, and then we're going to verify everything. And because we're doing something over time, what that usually means is we're going to need some sort of storyboard. I'm going to say storyboard equals a new storyboard. And then I'm going to start at the bottom, which is going to probably feel a little bit weird, but verify the storyboard. And if I run this, it's going to sort of have nothing in it, which is exactly what I expected this time. So then next, I'm going to create a Game of Life. So game equals Game of Life. And now I need to tell the storyboard that I have that. So I'm going to add a frame of the game. What I would like to see now is an empty board here. And I think, does that make sense? Or would you like a little more?
No, that's okay.
Okay, in that case, I'm going to hand it over. Make this test pass for me.
All right, so then if I run this, now that you created the class. Okay, so this is what is...
So it shows us the object, but it doesn't show us the object in a way that is helpful.
Yeah.
You're going to have to override the toString operator on line 19 saying dunder under, or it will start auto-completing for you.
So for this to be meaningful, yeah, we can for now just return an empty string, right? Because we don't know how big the board is. So if there is no living cell, then it's fine to return an empty string. Okay, so now it says initial.
So initial is like the first thing you gave to the storyboard.
So we need to place a cell. Well, I can either say add or resurrect. Which one do you prefer?
I like add, but I'm fine with either.
Okay, let's do add. And then I actually need a new cell here with 2 and 1 as coordinates. Right. And then this should actually be failing. So I'll be handing over to you.
So create the class cell and create the add. Ooh, it does not want to create the add. I guess I will have to create it myself. I'm going to use type hints. And the question of what should this return, I'm going to punt on that for right now. It doesn't like that because it doesn't yet know about cell. So it'll make cell ahead of it. So now we're passing. Ooh, we're not passing. Cell takes no arguments. Oh, fairly good point. Let's def init with an x, which is going to be an int, and a y, which is also an int. And I'm going to actually hold on to those, even though the test does not strictly require it at the moment. All right, so now test passes. The next step is to add the game again. So we have an initial frame, which is empty, and then the next one is still empty, but it should no longer be empty.
Yeah, so this is where I have to fix this, right?
Yeah, and I'm going to actually put just a little extra here because I kind of like it to be here, just so we're on the same page. So let's do an underscore, and then where did we put this? Put it at 2-1. So So right here, I want to see something. So that's sort of what I want. I want it to be at least one bigger than our most alive cell, so we can see that we sort of have an edge. And I want the live cell to be denoted. All right, make that work for me.
Let's create a field cells, and that should be an empty array for now. Then we push that cell onto the cells array. So what annoys me right now is that I either have to calculate how big our world needs to be to fit everything, or I need to make sure that we have a fixed size world.
Well, you can fake it, as is the nature of TDD. What is the thing that you're trying to calculate? Give me a name.
Okay, let's totally fake this for now. Instead of having cells as a simple array, let's go ahead and create that as kind of a, I don't know, a 3x3 matrix.
It's okay to do this like an array. It's just the thing you're trying to calculate. What were you trying to calculate?
I didn't have a plan yet. So my idea was that I was going to create a board that is exactly the size that we need.
So when you say size, what does size mean? Is size like a tuple?
I would say the size is width and height, yeah.
There's two ways I could do that. One would be width and height, and the other is I could say like size width, size height. Which one would you prefer? Alternative, I could say like just width.
Let's define two separate variables.
Okay.
Go through the cells array and then use a list comprehension.
I would point out that right now you are not faking it. Like if you actually want to fake it, just set it to 4.
Yeah, let's do that. Let's set it to 4 and 3, right?
And then just so that our earlier thing works, just check if cells is empty, and if it is, return an empty string. So we'll just do an early return, and otherwise width is 3 and 4. That is a fake. Nobody thinks that that's good.
Yeah.
I think it's Len, L-E-N.
I never understood why Python doesn't have this on the array.
I'm with you. It looks like you're going for a full fake. This should be an X. Okay, so we have it exactly wrong, but that's really common.
Yeah, not good was over.
Yeah, I like that better. So let's do if length equals 0. So that should give us sort of the same thing.
Yeah.
We're missing the spaces, so and the casing. So I'm just going to fake that a little bit better. Okay, good enough. So now I am going to try to make this. We need that width. The width is 4. And we need the height. The height is 3. And then we need sort of our board. That's an empty string. Okay, and then we're going to say for x in range 0 to width, because the x is the width. And for y in range 0 to height. And then we're going to say board.append. No, probably a plus equal. We'll see if this works. And underscore space. And then when everything is done, we're going to return board. We also need new lines. Board plus equal new line. I'm hoping this is close. No, but it's not. Because it's only going 3. Right, sorry. It's the other way. First we have to do the y, then we have to do the x. Let's try that. Okay, much better. So now it's basically the same, except for I don't have the x. So then here, this part, I'm going to put into an if. So if self.isCellAlive at xy, then I'm going to do a board plus equals that, and else I'm going to do this. And this, need to add. And right now, if x equals 2 and y equals 1. Okay, that is what I actually want. I'm going to move it over because it looks like we have some white space that I don't care about. So I've faked it less. I'm going to hand it back to you. Can you fake it even less?
Okay, so instead of adding the cell to the cells array here, I might actually do something slightly different. Introduce a new field in Game of Life. Next to cells, create a living cells, self-living cells. And it's going to be an object, an empty object for now. And in add, let's also add to this the self-living cells. And then in the square braces, basically I want a template string. 2 numbers, the 2 coordinates separated by a comma. We can even put it in regular braces so it looks like a coordinate pair. And then the value of this should be true. And then in cell is alive, I would like to do self, living cells. And I think there is this hash key or something like that in. Oh no, it's in. So, okay. I don't think we need the keys.
Easy way to find out. We do not. You're right. I'm going to handle the width.
Okay.
Get max width is what I'm going to call on self, I guess. And so we'll create that. And just to make sure I did this correct, I'm just going to return 4 again. Okay. And then next, let's extract that as a variable. So we'll call that width. And I feel like should be a nice way to do this.
You just call max.
Yeah, I like that. So we're going to say width equals max of cell in self.cells. I really want to say, would it be cell.x? So let's see if that works. Oh, no, it doesn't, because +1. Still not giving us what we want. So this should give us max of cell x. And actually what we want to return is width +1. But I'm expecting this to do the exact same thing.
With +1.
So this should 0, 1, 2. Oh, right. No, it's our range up here. But the max width actually should be 3. That should also have a +1. Because the max height should actually be 2. Bad calculations are something I do well. All right, so we're passing now. Okay, so that gives us max width. I'm going to guess the next thing is max height.
Yeah, and we can just copy and paste the code.
It's going to look very similar. There we go. Okay, now we're back to our test.
Yeah, but my guess is that if you go back to the code for a second, then we can now remove the first if statement. We don't need that anymore. Now it will actually do something sensible.
Well, let's find out.
It's going to fail.
I would expect it to do something different.
But it's going to be something that we are happy with.
It did fail. Is an empty sequence.
Okay, so now we actually have to add an if statement at the beginning of those to make sure that if the list is empty, then we return a 0.
And then we're going to have to do the same thing for height.
Let's see what happens now.
So now I'm expecting it to fail, but again, giving us something reasonable. So here, just saying, yeah. So we'll just move that over.
We actually like this better than the previous one, right?
Yeah, I agree. Completely empty strings, not as good. Advance the turn?
Yeah.
So lots of decisions to be made here. But one is game.advance turn. And the next question is, does this return us a new object or what does it do?
So since we are adding a cell on line 69, this is mutating the game object anyway. I would assume that we already made the choice that we are not going to do unmutable. So I would say that the advanced turn is going to mutate the object.
That's totally acceptable to me, but I don't believe that we have made the choice. I still believe the choice is open to us, to whether or not the game is advanced tail mutates or not. I'm going to just add in here the frame as well, so that once this works, we can tell if it's working or not. Because right now we can start it with, it doesn't work. Because frame 1 should die.
So what we could do is copy over and then correct it. Actually, we should be back at the first one, right?
Exactly. It should go back to the initial. I can make that pass very easily by just saying, so for mutating, it would be self.cells equals that. Oh, that's interesting. I have to clear both the way we have it right now. Self.cells equals self.alive living cells. Not my favorite, but I'm always good with a fake. Good. That is actually what we want.
Okay. And you know what? I would suggest that we do a bit of refactoring because we really don't need this cells at this point. What I would suggest is in add, instead of true, just put the cell into there.
So that should be a totally valid refactoring, which it is.
Still not delete. Find and replace for self cells, and for each self cells, replace that with living cells dot values.
Well, so this I don't even think you need to. I'll run it. This you're saying cells dot values. Yeah, that makes sense.
Actually, you don't even need to do that because the in is going to actually iterate the.
Let's find out. That's the thing I love about having tests is you don't have to guess. What is the computer going to do? No, it did not like that. There it is. Okay, it does need values. So now we can take out the add, take out that.
Yep, and let's see if it still works.
Good. And then I can take it out here.
Yeah.
Good. I like that. Just a little bit of formatting. So right now, advanced turn just clears everything. Should we create a second test that does something more interesting where it stays alive.
Yeah, exactly.
All right, so let's go back to our whiteboard. What's the scenario you would like to take a look at now?
We should look at one case where there are two neighbors for a living cell.
So like a blinker?
Yeah, like a blinker.
Let's do that.
What's interesting with this case is that the way we are going to implement it is that our approved test will eventually fail because our approved test will not be correct because it won't have the creation rule yet.
How about instead of a blinker, we just do a square?
But that's three neighbors.
Because then we only have to test one rule.
Okay, then let's do the three neighbors first. And then we can do the spawn rule.
Okay, so this I'm going to give a better name. So we're going to say test stable square or square, test square. So we still have our storyboard. We still have our game of life. I'm not going to put the frame in at the head of time because why? But we do need to add these. I expect, by the way, this to totally work other than the advanced frame part. Let's find out. Okay, good. So this part does work, right? Like we're showing that we can show the board correctly, but frame one is no longer good. And so what we actually want is this thing to show up here. All right, well, let me take a crack at this. What's a good way to do this? I like having all the cells before, so let's start with that for right now. This is problematic. Let's change this from living cells to just living cells here, and then say self.living cells equals living cells. And now I'm going to go through all my things again. So I'm going to steal this from here and here again. Not sure how I feel about this, but we'll come back to it. I'm still in a fakey thing. And then here, well, right now, it's just the cells that are alive stay alive. If self.isCellAlive at xy, then so ugly. Okay, so here we have this add and it creates this thing. What I want to do is sort of extract this, add cell to list. And I'm going to take this and pass in both the list and the cell. And then I'm going to basically take that, paste it to here, cell to dict. Okay, and then here, if I've done this correctly, this becomes self.addCell to dictionary. No, with the dictionary, which is this. Just because I don't like duplicating that logic because it's finicky. Okay, so now down here, I'm going to say self.addCell to dictionary. And the dictionary now is living cells. And the cell is it's just a new cell. Cell of XY. Okay, I'm not sure if I got this right. Definitely haven't gotten this right. Oh, possibly this shouldn't say empty, probably this should say living cells. Let's try that again. Okay, hold on. Now I've broken the first test because I'm not letting things die. So if it's alive and get neighbor count at xy equals 3. That seems like a complicated thing, so we'll come back to it and we'll just fake it for right now. Add a method here, and the answer here is going to be return, I don't know how to do a ternary. If the length of self.living cells equals 4, we return 3, otherwise we return 0. So both of these failed, but not in the way I was expecting. Type of Boolean has no length. Oh, right, because I don't know how to use parentheses. So now I have everything working. I'm going to hand it back to you and say, get neighbor count more real.
Actually, by the way, it's not that far off. Yeah, so if I...
Wait, hold on. I have a weird question. Python console for 1 second. Out of curiosity, true plus true, what does that equal? Oh, there's a very nice way to do this. Do you mind if I do?
Yes, you can try it, but first let me tell you what I would do. And then you can so what I would do is just return self.living cells minus 1.
Oh, nice. Self.living cells minus 1. Length of this. That is an interesting cheat, but it totally works.
With our test cases so far, this is actually the number of neighbors. If the cell is living.
Neighbors. Yeah, that's true. Okay, so now let me try mine, which is self.isCellAlive of xy, right? And then subtract 1 from each. And then I'm going to put these on different lines because, I'm not sure how Python likes different lines. Does it like different lines? Oh, wait, it's this. In which case, I'm going to do it this way. Okay, so then I'm going to move the x forward, so minus 0. Then I'm going to move the x forward again, so plus 1. And then I'm going to move it back again, so minus 1, but stay on the same line. I don't want the one where it's 0, 0. So I'm going to, oh wait, minus 0. So I'm going to plus 1 this. And then I kind of want this 3 things again. And now instead of y minus 1, it's going to be plus 1, plus 1, plus 1. And I believe, although possibly misguidedly, that this, what happened here? Wait, did it reformat something? Feels like it did. Let's see if that, does this, yeah. Let's line that up, let's line that up. And just because I'm anal, we're gonna, there we go. Nice and pretty like. I would argue if you don't care about white space, you shouldn't be in Python in the first place. Cool. All right. I feel like well, so there's one thing that we should ask is maybe we do this more than one time because this should stay like a couple times, right? Let's just go 2 forward. I expect this to work.
I think, yeah. Mm-hmm.
If I, again, typing, there we go. So the fact that all the tests, all the tests shouldn't have run. PyTest, there we are. Test all that. No. Why? What's going on here? Run all these tests. No tests were found. No, I've done something else wrong.
No, I know. Go down. Yeah.
That's what I did wrong. This is telling me right there. Okay, good. So now got the initial frame 1, frame 2. Okay, so you wanted a blinker. Are we ready for that now?
I think before the blinker, let's do the same thing, but only like we are going to start with 3 cells. We remove 1 from the square, and then we expect to get back the square again.
Okay, yeah, I love that. Let's try it.
Because then it will...
Wait, we're expecting to get the square? So can I just delete this one?
Yeah.
And give us 3. I think this is going to work.
And it doesn't.
Oh, that totally did not work.
And why?
Interesting. Oh, I know why.
Uh-huh.
Because we said we only do this if the cell is alive and the neighbors is. So really, we can just do it if the neighbor count is 3. We overdid stuff. Okay, so now we have, it's missing. Oh, but we haven't handled 2 yet. Okay, do you want me to handle 2 as well? So first of all, let's just state what the rules for 2 is. So it's if there's 2 neighbors and it's alive. Is that right?
I would say get neighbor count is in and then an array of 2 and 3.
Okay, so is in 2 or 3, but we also still need to say that it's alive. If self.isCellAlive.
Remove that. You don't need that and it's going to break.
No, you have to say that. That's what our English was. So I'm just going to go back. Look at the English. I deleted it too early. The English is if it's 2 and it's alive.
Ah, okay. Oh, because you wanted to have 2 separate ifs. Okay.
Self.getNeighbor.
In that case, you're right.
I mean, we can do the in as well.
No, we don't need the in then. Then we just do the end.
All right. But we do need the is alive. So self.isCellAlive xy.
Although,
and this.
by the way, the test would work without the is alive.
And this is sort of duplicate-y, so we're going to come back to it. The test will what?
This specific test would work even if you didn't include the is alive.
So I think what you're saying is 2 things. So the first thing is this test is working right now.
Yeah.
Right? Like we're happy with this. Check me if I'm wrong, but I think what you just said is, do you think we're done with Game of Life? Like it's, okay, so then what is a good test scenario for it's done?
The glider.
Remind me how the glider actually works.
Can I draw it? You got one there, you got one here, and then you got one here, and here, and here. That's how the glider looks like.
Okay, so I'm going to annotate. So let's say this is 1, 2, 3, and this is 1, 2, 3. And then I'm going to kind of put this just a little bit to the side and put PyCharm just a little bit to the side. Okay, so we are going to clone this again. I'm going to get rid of that pass because I don't really need that anymore. Test glider. The first one is 2, 1. The next one is 3, 2. And then the entire run of 3. So 3, 1, 3, 2, 3, 3. And just to make sure it works, let's take it like 6 frames.
Okay. Let's see what happens. Ooh.
Okay, so the first thing is our initial is not right. That's not what I wanted.
Yes, it isn't.
So let's go back and take a look. It isn't. So 2, 1, 3, 2. Sorry, this is not right. 3, 3. Okay, so let's see if our initial is right now. Okay, is that the glider in the initial?
Yep.
Okay, now the frame one. I'm not as familiar as the glider. Is this looking good?
That's perfectly the frame 1 of glider. And then you see the frame 2 is the same thing mirrored as the initial.
Yep.
And then on frame 4,
This mirrors as well.
and it also moves and makes the board bigger.
All right. That looks like we're done.
And this is surprising that we are done so quickly.
This is a happy surprise to me. There are some things I'd like to clean up though.
Okay, there is also one thing that annoys me, and that is that we cannot pass in negative coordinates at this point.
That is an excellent. Okay, hold on. So let me do two things. So I want to start by moving this to its own class because this is killing me now. So refactor, move, and we're going to move this to game of life. Good. And then I'm going to, this we don't need, that's just an empty test. I'm going to move this one as 2. So move to cell. Okay. And now our tests are our tests and that feels good. So I think what you're saying here is that if I had a glider that started negative, it's not going to work.
Yeah.
I'm just going to put a modifier on all of this.
Smart move.
Okay, it seems to be unhappy because let's say X is 4. That's a horrible name, but we're going to roll with it anyways. No. Alt draw. Alt shift draw. There we go. Minus X. Alt shift draw. Minus X. Okay, is 4 enough to get us off the board? Or should I do it a little bit more?
And rename the test.
Ooh, good point. Glider from negative. All right, so let's see what happens. Everything is empty, which is very interesting on multiple things. So the first question is, if it's off the board, I still feel like I'm comfortable with us not seeing it. But what I'm not comfortable with is it never shows up. I'm not sure how I feel about that, but like, let's for now say that that's okay.
Okay, I'm going to tell you how to fix it. And I think it's going to be really beautiful, although it's going to break one of our previous tests. In fact, it will probably break all of our tests. Instead of starting from 0, the ranges, we are going to create a get min width and a get min height.
I like that. Get min width, and then we're going to say min height equals self dot get min height. And for right now, both of these are just going to return 0 to make sure that I'm doing that correctly. Okay, so now how do you want to use these? So instead of 0, we're just going to start with min width. Wait, I didn't do what you asked me to. Min width. Do we need a -1? Oh yeah, we do. We absolutely do. But it works. So now the question is, let's actually do this. These belong near the other thing. We have things that are similar to this. Is it fair to say that this is the same as this, but with a min?
You could do that. Or you could do something really evil, but I think that's fine. Let's do it by copying and pasting. I think that eventually we should find a way to refactor this so that we don't have 4 separate functions. But other than that, this looks good.
I agree with that. Okay, so this is weird.
It is.
So stuff is coming in, but it's not coming in enough. It's weird here that, maybe 4 is too much, or maybe we didn't go far enough. Oh, whoa, no, we've broken things.
Yeah, we broke something pretty badly.
Because look, this X. All right, so let's go see what's going on. So get min width. So here we did a +1. Maybe we do a -1. No, this is the problem. Min. Let's try that again. Okay. So first of all, step 1, everything else worked except for the glider for negative. That's good. Step 2, in the glider for negative, he starts to pop in. It feels like we need more frames.
Yeah, but go back for a second. Can you show me where we printed?
Yeah. So we're printing here in the string function.
Yeah, that's the problem. We also need the min width and min height there.
Okay, so that will definitely change things. Let's go and do it then.
I want it to change.
Okay, you want it to change. So now it's always going to move. Okay, we'll do that, but then I'm going to have more to say. Okay, so we're going to put in here the min width and the min height. We're going to change this to min height and min width. And if we do this, we expect lots of stuff to break. Well, only one thing to break. But it's now no longer telling us where it is. So now I want coordinates.
Okay, fine. Add coordinates. The only thing you need to do is print the min height and min width, and it's going to tell you where the top left corner is.
That's a great point. So the top left corner is going to be min height. I'm not sure I have this right. Have I confused my X and my Y's? Height is Y, right? And then we're going to put a new line. Okay, so let's see if that... Okay, so starting at 1, 0, starting at 1, 0, starting at 1, 0, starting at 1, 0. I like that a lot. This is good. So I'm going to move all this over. Let's see what else we got. Starting at 0, 0, starting at 1, 0, starting. Yep, I like that a lot. Very clear. Okay, hold on. This one, I like, that's our last one. Okay, so here at 0, 0. Oh no, this is good. 1, 0, 1, 0, 1, 1, 1, 1. So, okay, so this is good. We have a little less white space because it's now sort of tracking where the stuff is.
Yeah, and that's what I like about it. It basically follows the action.
I missed something, I feel like. Yeah. Okay, so now it starts at -4, and then moves over, moves over, moves over. It never actually gets to positive.
Yeah, but that's not a problem.
It's not a problem, but I do like the idea of it crossing a border.
Then do more iteration.
I can do that. How many more do we need to get it from 4 over the board?
Let's make it 24.
Let's do it. Okay. So we're at -1, -3. We're getting to the negatives. On 13, we actually start to cross over. Oh no, we're actually positive before this because it's starting negative, but it goes over. Okay. And the glider keeps going. This is great. Okay. Okay.
All right. Let's do a bit of refactoring.
Just clean up a little bit of cruff here. Delta. Okay. All of that was just noise that we hadn't cleaned up. Oh, I forgot one. Okay, now what would you like to do?
Okay, so one thing that I want to do is go to our production code, and there is a function, the add function, and a bunch of other places where we create this thing here, the add cell to dictionary thing, right? And what I want to do is I want to move in the square brackets.
There's actually only one other place that we do it. It's here. You want me to pull that out as a method?
A method into the cell object as the toString method.
I like that a lot. Okay, so this here is going to become cell dot. That's not the way to do it in Python. That's the way to do it in Python.
I'm not even sure, by the way, if Python would automatically stringify it for you if you just put it in the square brackets. I know that JavaScript does.
So let's get it to work, and then let's test that. Okay, so that does work. I
agree.
And then the idea is, do we even need to do this? JavaScript would. I would hope Python wouldn't, but we'll find out. It does not. I would hope a dictionary is any object. Given that we're doing that, we could not stringify it and just simply here say, oh, but that won't work. Oh no, we have to stringify it because we don't have a comparison equals on cell. But here we can at least say string of cell of xy. So that now should go away. What else would you like to do? Would you like to take this duplication out?
Yeah, that duplication would be nice to take out.
This is easy to do. Duplication coloring book does this no problem. So all you do is you hit copy here, go up to here, and say compare with clipboard. It's going to come up and say, okay, we need a max and we need a minus. Really, it's going to be a -1. Okay, so if we go here and we close this, the first thing we have to do is we have to say, we'll call it function equals max. And then we should be able to use that function here. We'll see if that works. It does. I now should be able to do the same thing here. Function equals min. And say function here. That should work. And then we need that modifier. And here it's -1. And so this is going to be really weird, but I'm going to plus the modifier. And that should work. And then here, I'm going to do the modifier again and plus the modifier. And have I done everything correctly? No, I did not, because I copy and paste a little too much. Let's try it again. Good. Okay, and if I've done everything correctly, now if I copy this on my clipboard and compare it to here, these should be exactly the same, which they are minus white space. So now I'm going to extract this as a method to get extreme. So we'll call it that. And it even figures out that it will do it in both places. Yay, PyCharm. And then I'm going to inline this and inline that and inline this and inline that and run that. Okay, and now I want to do that with the same thing here. But the problem here is this X, right? This cell.x, because here it's cell.y. And so I need to pull that out. Yeah. And I don't think I can pass in a thing. But what I can do is I can pull this out. So here I'm going to say field of cell. And up here I'm going to say field equals lambda c goes to c.x. If I've done this right, well, we will see. Okay, yay. And now I'm going to pass this in. So in here I'm going to say, actually I have this slightly in the wrong order. I'm going to say the max of this with 1. and the max of this with -1, and I'm going to put field in here. And let's just see if that works, because before I do more things, yep, okay. And so if this is now right, to get the minimum height should be this, but with Y. And now to get the maximum height should be this, but with max and 1. And yay, duplication coloring book for the win. All duplication can be handled this way. Except for this get extreme.
How about we get rid of a bit more duplication? So what I'm thinking is, could we just create a get extremes? So there is a get extreme function, and then let's do a get extremes that returns all 4, and then we are just going to decompose a list.
Oh, I love that. Okay, so we're going to say here, we're going to say get extremes. How about get borders? Get boundaries. Boundaries. And the idea is going to be, this is going to be width. No, this should be min width, min height, width, and height. So we're using parallel decomposition. Is that right?
Yeah, we just need the self before the get boundaries.
Really good point. Add method. And so this is going to return pretty much the same thing. So I'm going to copy so that I can remember. And this is going to become self.get min width. Self.get min height, self.get max width.
And then you are just going to inline those, right?
I'm not sure we want to inline those, but we'll come to that in a second. Oh, do you want to? Oh, okay. Get max width. Sure, why not? Self.get max height. Okay, so let's see that actually works.
It does.
Then we're going to do the same sort of trick that we did before, putting these on separate.
I think you might actually need to add one more space between those, before those backslashes.
There we go. And there we go. Line that up. Okay, but this is still used here. So let's do the same thing over there before we inline those. Okay, and then inline these is what you want. Inline all and remove the declaration. Inline all and remove the declaration. Nope. Inline all and remove declaration. Interesting that it doesn't remember my last choice. Let's check that. All right. Anything else?
Yeah, let's scroll through and see how it looks like now. Okay, I just want to rename the variables on 39.
Okay.
Let's call it min x and max x, and then min y and max y.
Do x min.
Okay, that's also fine. I can live with that.
Like that.
Yeah, and then move the get extreme function to the bottom. That has nothing to do up there. It's way too high. Okay, and seems reasonable.
I like that. I'm going to redo this so that it looks the same. So this is x min, y min, x max, y max. I feel pretty good about this code.
Yeah, me too.
What is that? Oh, make it static. That makes sense. Yeah, sure.
All right, so let's do a retro.
Yeah.
Let's do your kind of observation retro. I really like that format.
All right, let's do it. I'm going to open up a mind map, game of life with approval tests, and then we'll start with pedal. So this is patterns, emotions, tools, team, domain, and language. So what did you observe?
I'm not sure. It maybe it belongs to tools, but like the way we did TDD approval tests is that I felt like by the end we got done too quickly, in the sense that I had this uneasy feeling that did we test everything? Did we really test everything?
I'm going to put this under surprise when we got done too quickly, and then I want to put in those questions. So there was maybe surprise. There was also on there what you're saying is confusion. So like, did we test everything? What was the other question you had?
Yeah, and in fact, I believe that we even tested more than.
So if the first thing is like, did we test everything? Did we test too much? That's beautiful.
This is Schrodinger's confusion, when you are feeling like you both tested too little and both tested too much at the same time. It's a superposition.
Okay, so there's two things that are interesting. For a long time, emotions were very confusing to me, and I just basically avoided them at work. And then I read this book called Language of Emotions, which Arlo Belshi introduced me to. And it's not a very well-written book, but it's amazing content. And the sort of takeaway from there was, emotions are your system one, or your subconscious brain pattern recognizing that something important just happened, right? And both pay attention and probably do something, act, right? So something important happened, pay attention, act. It's trying to tell you. And the only way it has to tell your logical brain this is through the bandwidth of emotions. So confusion is saying, slow down, you might be missing something. Like it's trying to get you to slow down. Right? And so that's probably why it's asking, did we test everything? Did we test too much? Like it's trying to get you to slow down and look at the situation. Surprise, on the other hand, is two things. If it's a happy surprise, then it manifests as joy. And in which case it is saying something unexpected happened, pay attention so that you can repeat it, so you can do it again. Like, wouldn't it be nice to be done too quickly again? But yeah, this is great. What else did you notice?
This is probably the theme. But like we have, I think, very different styles of coding, yet we still manage to work together pretty effectively. So I think I kind of let you go your way sometimes, but sometimes I also gave you input. And I think that the result was a piece of code that is probably somewhere between your style and my style.
I agree with that. And so one of the rules that we use in mob programming is a yes and. And so the general rule that I try to follow is whatever you put down, I don't want to remove it, right? So I want to build on top of it, right? Like we can refactor it later, but I don't ever want to like delete it and do that. I want to just move forward with whatever we have. It feels like you also sort of, maybe not like explicitly, but intuitively follow that pattern as well, because it was very comfortable to work with you. Mm-hmm. So one pattern for me, I feel like most of our time was in the code, not the test. Like we spent very little time actually writing tests.
Yeah, that's true.
Does that make sense? And that is something that I notice a lot.
Also, our tests were a bit brute force.
And they were and they're big, right? Like, I mean, they're not big conceptually. Where's our whiteboard? Here's our whiteboard. So our tests are easy to write on the whiteboard. We did the single block, we did the 3, we did the glider, and then we did the glider off the board. So conceptually, they're easy to say. And then when it comes to filling them in, we did a lot of like what I would call partial steps. Right? Some of that was the faking it, right? But the other part was like only caring about like frame 1, right? And then 2, and then 3. So like we'd only care about part of the problem and say like, are we making progress that way? What else did you notice?
Yeah, about the language. So one thing that was interesting for me is the way that Python handles for loops, that we have to tell the range that resulted in a solution where we automatically track the action, which I really like. I have never seen a solution that automatically tracks the action.
Nice. Yeah, we kind of got that for free, right? Like free tracking of action. That was kind of nice. I like that. So we have this range thing. We also had this thing where it was like for A.B for A in C. Am I writing that right? I'm not sure if I am.
Yeah, that's list comprehensions. That's a really useful thing in Python.
That was nice. It's not a syntax that I'm used to.
Actually, let me jump back a bit for the did we test too much part. So one thing that I would argue is we can delete one of our tests.
Okay, so I have an idea on this too. Yeah. So I want to see if it's the same as yours. So we're going to go 1, 2, 3, and then we'll both say what the test is. Okay, so we have the test glider for negative, test square, and test with approvals. So then on 3, tell me which one we don't need. Ready? 1, 2, 3.
Test glider. Yeah, but I'm going to go for more. I'm going to say that the only test we need is test glider for negative. None of the others are necessary at this point.
Yeah, you know what? I kind of agree with you because the test glider tests all of these things. So it tests everything. This is fantastic. I still like that we built them up that way. Only needed test glider. Yeah, I agree. Only needed glider negative in the end. Okay, other observation. So, I mentioned before, like, we need to be able to recognize success. Like we don't have to be able to define it, but we need to be able to recognize it. And to that effect, I felt like we could the whole time. It was easy for both of us to be like, yeah, that's right, that's not right. Even to the point at the glider where all I could say is, Yvette, is that right? Like I was still able to ask the question.
Okay, I'm fairly happy with this.
Yeah, me too. I think we might be at the end.
See you at the next Team Poker, I guess.
That would be lovely. Thanks so much.
Thank you. Now you know how to automate writing automated tests using approvals. Pretty neat, right? Next, you could watch this earlier episode where I turn everything into functions, or subscribe to this channel for upcoming similar content. Would you like me to pair code with other engineers next time? Leave a comment if you have someone you'd like to see me pair code with. Until then, keep coding and carry on.